polar coordinates. Polar. As opposed to, do you know what the other kind of coordinates are called that we usually use? Rectangular coordinates. Okay. So the polar coordinate system is a plane with point 0, which is the origin in our rectangular. Now it's called the pole. Okay, and a ray from the origin. It can go in any quadrant, just like any other thing, but your point right here looks like this. It's how long is it? That's your R. You can see my R there. I just almost messed up here. That's how long that thing is. And then the theta is the, usual terminal side on the polar axis. The polar axis is this initial side that we talked about when we did the trig, okay? And then the theta is the distance in between the initial side and terminal side, okay? It's a directed angle, so it can be positive or negative, okay? So if it's negative, it would go this way, okay? Just like normal, all right? So let's take a look at how it works. We've got the rectangle coordinates 4, 3. So go ahead and grab that. We learned this in like 2nd grade, probably. Honestly, the first quadrants we probably were introduced in very low grades, and then they started introducing the negatives. But so we go on 4 and up 3, right? Okay. So what happens is, what we're going to do today is you're going to call that something different according to what this length is. Okay, that's going to be R. And remember, this is 4, and this is 3, because that's how we situated that. So the R, of course, is 5, because that's your Pythagorean stuff. So polar will be 5 something, okay? And the something is going to have to be what this theta is. Okay? So, how are we going to find theta? Inverse what? Anyone, but yeah, let's start with tangent of theta equals what? Would be, what's the 3/4? So theta is going to be inverse tangent of 3/4. Now that is not one you would know. So you go to the calculator and you set up degrees. Usually, it really doesn't matter. It'll be a combination. So we'll go ahead and do degrees. So our mode is going to change to degrees. Mine's already on degrees. Inverse tangent 3/4. 2.75 if you'd rather. The degrees is 36 points. So we put that right here. 0.870. Oops. And if you're using, let me make my print stuff big enough. 36.870. Put your degree mark there. If it's radians, then you can leave it off. And it will vary. We'll do some degrees, some radians. If you know it's degrees, put degrees. Otherwise, radians, it doesn't have to put a unit. Okay? So we're going to go from rectangular to polar. We're going to go the opposite way too. But that's how it works. Okay? Any questions so far? It's the same name. It's a different name for the same thing we've been doing. Okay? All right. So we already talked about this, but angles can be positive or negative. Let's see, attached here. Okay? They can be measured in radians or degrees. Okay? R can be positive or negative, which is different than last chapter. R was never negative. Okay? But remember, polars are directed, so if R is negative, then it's going to do something different. So this was what we just had. If R is positive, it was a positive 5 from before. P, right here, if R is positive, P is on the terminal side. Where am I? Right here. Which means I don't have to move. Now this right here, from here to here, is 5, according to this diagram. Okay? Now, R0, what we need to do, here's the language. P is on the terminal side of theta plus pi. Okay, pi's in radians. All right, where would that be if R is negative? That's right. It backs up like this. So say this is R right here. This is the same size, it just is a different quadrant, different direction. Okay? So basically what I like to call it, I don't do this because it's just like, what does that even mean? But I just say you have to back it up if it's negative, which makes sense. So frontwards is this direction, backwards is the opposite direction. Okay? So if you wanted to graph, let's graph negative 5, 30 degrees. Okay? And we're going to do this. I'm probably getting ahead of myself a little bit. So the 30 degrees would be about right here. And let's say 5 would be 1, 2, 3, 4, 5, that long. Okay, because those are diagonal lengths, they're not the same as the shorter lengths. Okay, because it's negative, we got to go back this way, and this lands in the third quadrant. 1, 2, 3, 4, 5. This is the point, negative 5, 30 degrees. Okay, yes.
And the 30 degrees would be
this right here. That's 30 degrees, so is this. Yes, that's what you were going to ask. Yeah, that's the same. But that R being negative backs it up over here. Okay? Anybody else? All right, let's try a few plot points with the given polar coordinates. Let me show you what a polar, the next page over, I hope they showed up better than that. You see them?
yeah.
I don't know why, but they're supposed to be concentric circles. Okay? I don't know why they're not showing up. Are they? Can you see them?
Yeah.
Okay, so I'll just draw them. Let me get this on single page. Okay, so your graph, your polar graphing paper, if you ever Google polar graphing paper, it'll look like that. Okay, that's enough. Those are concentric circles. Okay, pi over 4 would be right smack in the middle. So this is pi over 4. Okay. And then 2, if you see, you have one circle, that's a radius of 1, radius of 2, thus the concentric circle. So that point right here is right there. That's the reason for the concentric circles, because that'll give you your radii. Okay? So otherwise you're just guessing, like I did here, I just guessed what 5 was. But if I had my circles, then I could tell you this is 1, this is 2, then et cetera, et cetera, et cetera. Okay? Does that make sense? All right, so I'm just going to draw them on here since I got to go out to 4. So here's 1, here's 2, here's 3, here's 4. Okay. So I have a positive R of 4, and I have a negative 2 pi over 3. So negative 2 pi over 3 means I'm just going to go this direction. Okay? Where am I going to land? In what quadrant? Third? Okay. So let's see. That would give me, that would be about right here. Because this is 3 pi over 3. So this is negative 2 pi over 3. That's a pi over third. Okay. And then 1, 2, 3, 4 would be right there. Did you have a question, Lauren?
Yeah. Do you have to put like the line or just the dot?
The dot. Yeah. The dot is really where it is, but to determine it, usually use the line. But yeah. This is a point, so yes, it is just a dot. Good question. Okay, 50. Oh, sorry. Yes, it would. So good question. If this was 4, -2 pi over 3, then that would make me go here, and then I'd back up to here, and that would be this one. And you'd have to back it up. So yeah, whatever it is. Okay, 50. Where is that, Amanda? So 1, 2, 3, 4, 5. It's right there.
Yeah.
Yeah. It's the same place as it was if it was rectangular coordinates. That's still 50. Okay. All right. What about D? 3. All right. So yeah.
Should be in the third coordinate because
Quadrant.
third quadrant.
Yeah. So pi over 3 should be about right here. That's pi over 3, and then back it up 1, 2. Good job. Okay? That makes sense? So that's graphing, plotting points. It gets a little nutty because, Lauren asked about the line, but the line really should be pretty close. You don't get to just say, oh, it's about right here. Okay, or it's about right here. You need to, if it's in the middle, then it needs to be in the middle. Okay, just like 4, 3 should be over 4 and up 3. You don't get to just like put it in the right quadrant. It needs to be relative to, is this pi over 3, so this is pi over 6 deal. Okay, yes.
Okay, so is it like pi over 3 like in third quadrant? Because you kind of have it like as a straight line, so I'm sorry. So, is it like pi over 3 from the axis?
This right here, this angle right here is pi over 3.
And then on the third quadrant?
And then remember your vertical angles. This is pi over 3.
Okay.
Because this is 180 degrees right here, which is that pi that we're talking about. Pi over 3 is your 60 degrees. Okay, got it? All right. Okay. All right, I'm going to get rid of this. Okay, so this is same idea, but letting you know that there's not one way. When you have a rectangular coordinate, you say, okay, here's your one description of that. Polar coordinates, as you can imagine, you can keep going around the circle, which is what this is. PF polar coordinates are and theta, okay? Any other polar coordinates must be r theta plus 2n pi. This is just going around the circle again. 2 pi would be around once. So let's say r theta is right here, okay? If you go around again, you'll land right there. This would be r theta plus 2 pi. Okay, go around again. R theta plus 4 pi, et cetera, et cetera. That's what this means. That make sense? Okay. Then the negative r is the same idea. The negative r says the theta. Then to back it up, you have to add the pi, and then you can keep going around with this. Okay? And then this is just this combined. 2n plus 1. This right here is just algebra right there. It's the same thing. Okay, right? You take a pi out, you get 2 pi. 1 plus 2 pi. Okay? And 2n, sorry. Right? Pi 1 plus 2n. That's what that means. So it's just algebra. Okay? All right, n is any integer, so we can go, we can go negative direction, we go positive direction. Okay, so let's do there's a piece on the homework that is very specific about, okay, here's your original polar coordinates. Now, with these stipulations, find 3 different points to describe it. Okay? All right, so let's do 1, 2, 3. I'm just going to graph it first. I think we've graphed this one before. It's about right here. 3 pi over 3. All right. Now, I wouldn't really worry about this language. I would just understand how you get there. Okay, r is greater than 0. You want r on this problem to stay at 3. Okay? All right, but now we want theta be between 2 pi and 4 pi. Okay? So that means, what are we going to do to this pi over 3? Add 2 pi. So pi over 3 plus 2 pi gives me 7 pi over 3. 7 pi over 3 is between 6 pi over 3 and 8 pi, no, 12 pi over 3. That's what the pi's are. Okay. This time we want, again, this is the final one. That's the one we want. That is in the same spot. That's the whole idea. We're not moving spots. We're just saying, call it something different. Okay. R is less than 0. So now R is not going to be called 3. It's going to be called -3. Okay. So where are we going to, if we're going to have to back it up, to be -3 and to be here when we back it up, what's it going to start as? Lydia? So you want to take pi over 3 minus 2 pi over 3? Minus 2 pi?
Yes, I believe so.
Which is what?
That should be, -5 pi over 3.
Okay, well, let's try it out. -5 pi over 3 would land us in what quadrant? This is -3 pi over 3. -5 pi over 3, wouldn't it be like right here? Okay, and then that means we're going to back it up, so then that would be end up over here. So that's not what we want to do. But I got a different suggestion. Lauren? 3 pi, say it again? 4 pi over 3. Okay. So she's, okay. First of all, we forgot about that maybe would work down here, but our theta needs to be original between 0 and 2 pi. So Lauren says it's 4 pi over 3. So let's see. 4 pi over 3 would put us, here's 3 pi over 3, here's 1/3 pi, and then we would have to back that up 180 degrees. So I'll let that is. Okay, where'd you get it? Can you explain the process for us?
Yeah. Well, since
R.
oh, so yeah, I'm trying to remember. R has to be less than 3, so you know that
R has to be less than 0. So R has to be negative.
So you know that it has to be -3 basically. So then whatever the angle is, it has to be on the opposite side of where the current angle is. And so
Okay. So you knew to land it here. You knew this was pi over 3. Okay, so you knew you had to figure out what that angle was. And because it's 0 to 2 pi, you know you're going to go positive. This time, you have R is less than 0, and you have a negative theta. So it's the whole, the principle, what Lauren just said is the same. You want to end up there and then back it up into the first quadrant because of this negative R, okay? This time you want a negative angle, so you want to go around the other way. What is it, Bridget? Very good. So you just got to understand where it's going to land and figure it out. I would not worry about doing this business up here, because I think if you just remember, if I'm going to back it up, that's how it's going to go. rather than just kind of random things. Okay? So the point of this is, with rectangle coordinates, each point has one pair of coordinates. Polar coordinates, we could go on and on and on, and make, maybe we want to make theta 2 pi to 4 pi, and r is negative. Okay, we could just keep going and going. So just keep that in mind. There's not one unique way to describe a polar point, or a point in the polar system. Okay, so we're going to convert now to polar, and we're going to go to rectangular. So these are the coordinates, polar coordinates to rectangular coordinates. While we're looking here, we're going from rectangular to polar coordinates, and then we're going to take equations and transfer those. Okay? So those are the three things we got to do yet. All right. Let's see. What do you think the relationship is between x, y, and r? Very good. X squared plus y squared equals r squared. Okay? What do you think theta probably is going to be? I should have turned that the other way. And sometimes remember, we can put it in any quadrants. This is theta now. But we'll call that theta for the, So what's, r could get messy because it's a radical sometimes. What's the relationship between y and x and theta? Claire? Okay. So tangent of theta equals y over x. Okay. All right, there's two more under there. You all didn't know there was a little, okay. We got two of them. This is what I call my toolbox of polar coordinates. There's one we talked about. There's the other one. Okay, let's talk about these two. X equals r cosine theta. Okay, and y equals r sine theta. All right, let's get those written down. Okay, regardless of, here's cosine theta equals what over what, according to this triangle right here. What does it look? What do we get? Cosine theta, Leah? X over r. So when you take x and you multiply both sides by r, that's where that other one comes from. So this one comes from. And the sine thing works the same way. If you do sine theta, it equals opposite over hypotenuse. So when you multiply by r, you get the other one. Y equals r sine theta. Now, those need to be probably memorized. Remember, y is always with the sign. It was on the unit circle as well. So keep with that. Same with x is always with the cosine. Okay? All right, so we're going to use this toolbox to figure out how to change from rectangular coordinates, from polar to rectangular. Okay, this is polar. And we're wanting to know rectangular. And honestly, they still look like a ordered pair. So be careful. I mean, they're not going to look much different except that you don't usually have that in terms of x and y, that pi distance. Okay, so let's see. We need an x and we need a y. We have an r and a theta. Okay, so if you use this, x equals r cosine theta. Okay, x equals r, what's r? 5 cosine theta, what's theta? Pi over 4. Just when you thought you were done with the unit circle, you're not. So what's pi over 4? What is it? Square root of 2 over 2. Good job. So x is 5 square root of 2 over 2. 5 square root of 2 over 2. That's your x from your ordered pair, rectangular coordinate. All right, the y is going to be done the same way. Y equals, from your toolbox, r sine theta. R is 5, theta is I'm getting ahead of myself. Pi over 4. Sine of pi over 4 is the same thing. There's your y. You're done. Okay? The only reason you had them the same is because the sine and the cosine of pi over 4. Okay? Any questions? You want to try part B by yourself? Try it. And then I'll look around and see here. Different ways we can approach this. I'm going to start the same way. X equals r cosine theta. R is -2, cosine theta is 5 pi over 6. Okay, 5 pi over 6 is right here, correct? What's the cosine on that little pi over 6 guy? Start up and go up. So isn't that the top one? No, that's the bottom one. Okay, sorry. So square 3 over 2. Okay, because all students' cosine should be negative. All right? 2 cancels, and we have a positive radical 3. Right? Did you have Leah? All right. Radical 3 is my x. Okay? Now, the other school of thought is, let me just finish. Okay, so y equals r sine theta, -2 sine of 5 pi over 6. Remember the co-functions. So that's all students, that's a positive 1/2, right? So what do we get? -1. Okay? So if you didn't graph it, you wouldn't have anything to check, but to graph, we would say, all right, how would we graph this? We start with the angle. Where's 5 pi over 6? Second quadrant, about right there. Okay? And then because it's negative, we got to back it up to here. So this is where this should be, correct? All right. Radical 3 minus 1 is reasonable as far as the signs go. Okay? Remember this, what is the ordered pair on a unit circle on this guy right here? That's the little angle, so that's the bottom one. So it's what? Radical 3 over 2 1/2. Start. 1, 2, 3, 1/2. Yeah.
Would it not be negative?
Right, yeah, we haven't, yeah, I gotta adjust that. Okay, so we gotta do negative, and then you're gonna multiply those by 2. So that's why, oh, sorry, I put the negative on the wrong one, didn't I? Positive, negative, over and down, okay? And then that works out, okay? So, any questions on that? Did y'all do it like that? Just watch your signs. That always seems to be where we're going to end up. Okay. Again, we have already done this a little bit, but we're going to do rectangular to polar, -1, negative radical 3. Okay. These are going to be familiar angles for the most part in this section. If they're not, then you'd have to do something different. So -1. Negative radical 3 would be about right here. Okay, we want to know what that's called in terms of, this is rectangular, we want polar. Okay, I'm going to give you a minute. Since we've already done it. Shoot. Okay, thank you. All right, so we're going to take our equations. This is a polar equation. Okay, really we're going to do a lot of graphing next class, but let's just go to our mode on our calculator. And if you go down to function on your mode, and then go over to polar, hit your enter. Okay, make sure you're in radians as well. Okay. All right. You are going to now look. You don't have y equals, you have r equals. That's kind of standard for polar form is that you start with r. Okay, it doesn't have to, but that's kind of standard. So like if we want to do 4 sine of theta, now when you hit that X button, you remember you hit X, and there's also a T, that's the parametric that we don't do, and there's a theta, and that's the theta. Since we're in that mode that says function, not function, not parametric, but polar, that's the third thing. That's why that shows up then. All right, where am I? And what does it look like? It's a circle. It doesn't really look circular because remember our grid there is not square, it's rectangular. If you want to make it look circular, go to your window and hit about, let's see, let's do window zoom and go to square, Z square, number 5. And then it looks more circular. But if you look at your window, it's set up to be different. You also have a theta minimum and maximum, you have an X minimum and maximum, and you have a Y minimum and maximum. Okay, so it's getting a little bit complicated already. More so. Okay, so you want radian and you want polar when you're graphing. Okay. Now, we'll do the graphing next time, but I just wanted to show you. These get pretty cool. And this is what we're going to do. Like, you could get some random, I'm going to show you some basic, like, slide a little 4 in there next to the theta and see if it turns into You're probably not in. You have a different window. The window, you all will make a humongous difference. So let me just square. Let's see. Let me just change it. But I mean, you change like this is what is kind of like maddening if you're really trying to plan something. First of all, you know, we're going to play around with the graphing here in a minute, but not in a minute. Next class and the next class, but that's what your project is going to be, create something fabulous from just playing around. Because your knowledge in these 2 days I'm going to teach you polar is like nothing, okay? So you're just going to have to see, oh, well, what happens if I square this? Let me square theta and just see what happens. Oops. I mean, you're just going to be like, oh, well, let's see. Okay? So, I mean, and you're like, wait, I don't like that. So then change the window. And like sometimes it changes completely. It's so bizarre that you change one thing on your window and it's like a totally different picture. So anyway, we'll mess around with that. I took some beautiful pictures from you, but this is without the calculator. We're going to take our equation, our polar equation right here. It's polar because it starts with R. X and Y are with your rectangular equation coordinates, and then R and theta are with your polar, okay? All right, so there are 2 techniques, And pretty much that's all it works. You can either multiply both sides of the equation by r, or you can square both sides. Okay, so let's see. What do you like? Not knowing what's going to work, let's just try number 1. Multiply both sides by r. So that's going to give us this. Okay? Now, if you know your toolbox polar stuff, that really looks pretty good, because what is r squared equal to in terms of rectangular x and y? X squared plus y squared. And what does this look like in your toolbox? That is not x, but you're close. That's y. And now you have x's and y's. You have a rectangular equation, or an equation with the rectangular coordinates. I don't know what you would call it. What would be better? Equation with, yes it is. Well, we already knew that from looking at the graph, right? Okay. Okay, that's good observation. Equation with rectangular coordinates. You can call them that. Now, if we were going to graph this, Aaliyah already said, oh, it's a circle. Okay? Well, how do we graph this circle? Yes, ma'am?
Wait, I have a question.
Okay, go ahead.
So what you did was multiply both sides by r.
Yes.
Right? So would you not have to distribute r?
No, because there's no addition. There's no addition. Distribution is, you know, with addition. I just kind of stuck it in there just because I kind of knew that r sine theta was going to be something. So, but good question. There's no distribution because there's no plus or minus. All right, so how do we make this look like a circle equation? It looks like a circle equation. Okay, tell me what the center and the radius is. She thinks that 0, 0. There's a y there. Okay, so what's the standard equation for a circle? That's if you have the center at 0, 0, right? What if it's not at 0, 0? Okay, so the center is at HK. All right, so what we're going to have to do is we're going to take this and, because of that y, it's not going to be around the center. Okay, if it was x squared plus y squared equals 10, then we'd be done with it. Okay, so what is that process called? Completing the square. Who said that? Maria is so smart. Oops, I don't want to say her. All right. So, okay, how does that look? Hardin County. Isn't that close to you?
Yeah.
Say hello to my boyfriend. Your boyfriend. All right. So you can tell me how to. I've got this completed. I'm done with the 0. Now remember, you need to really make yourself remember that we're going to add something, and then we're going to add the same something over here. Okay. Remember this? Completing the square. So this needs to be a perfect square trinomial factored here. Clear? Okay. That's not usually the order, but where did 4 come from? Yes. So you take half of this -4, remember you put it there, you square it and add it to both sides. Okay, good job, Claire. So 0 plus 4 is 4. All right, now we know it's a center, it's circle, center point is what am I writing? Circle. Center is what? 0, 2, and radius is 2. And if it doesn't say to graph it, just says to identify the, what am I doing? What's going on? Okay. We could graph it, right? 0, 2 is up here. And we go up 2, over 2. Here's your beautiful circle. You've seen a better one? All right, birthday girl. Center. It's a little lopsided, but anyway. All right. So there's your center, and your radius is 2 as well. So you are going to be, in order to identify it, you need to show that, oh yeah, that is a circle. Okay, any questions? We did that on the the skill practice. Occasionally we've done that, right? Any questions? Okay, squaring both sides. I just started with number 1. Let's see what happens with number 2. Step 2 said we were at R equals 4 sine theta. Okay, we can do anything we want as long as we get to both sides, right? Okay, so R squared's good. What's 4 sine theta squared? 16 sine squared theta. Okay, this could be taken care of. But what in the world are we going to do with that? Or not. So this isn't a good method. But you don't know it until you do it. Sometimes it works. You try it. If it doesn't work, you try the other method. Okay? There's, you don't really know. Again, you have very little background, as in 0, with polar stuff. Except for today. That's your background. So you just try something. If it doesn't work, you try the other method. There's 2 methods. Okay, I think we have one more problem, don't we? All right. Okay, where'd my equation go? Oh, transform the equation of the circle with radius 4, centered at 0, 0 from rectangular to polar coordinates. So, what's my rectangular? It's a circle. Radius 4. X squared plus y squared equals 6. Okay. All right. Okay, so that's our rectangular equation. All right, now what?
R to the 4.
Yes, ma'am. I wanted to do that first. When I first did that, I was like, well, R equals 4. I'm like, well, duh, that's our polar equation. We're done with it. If you really were thinking hard of not even going there, x squared plus y squared is what? R squared? R squared equals 16, R equals 4. Okay? And remember the basic equation when you have polar, it doesn't give you choices for R equals plus or minus. You would have to do R equals 4 and R equals negative 4. What does that look like? There's R equals 4, there's R equals negative 4. See, they're the same thing. Okay, so anyway, if you can get that right there, you're looking for polar coordinates, this is it. Okay, a polar equation.
So you wouldn't have an angle, you just have that?
Correct. Correct. Yes. You don't have, the bottom, basically the bottom line is for rectangle, let's talk about rectangular equations. Remember, we don't always have to have an x and a y. We can. Okay. We can have x and y. We can have just x. We can have just y. Okay. Same with polar. we can have just R. We can have just theta. That's a polar thing. Okay. Let's take this. What do you think that graph is? Theta equals pi over 4. I can't put it in here because I'm supposed to start with R. It's sort of like, you know, the problem of x equals 5 and you have y equals, you can't do that. So it's the same problem, but how would you change it? My advice would be to change it to rectangular form, because we know how to graph in rectangular form. Okay, any suggestions? Change to rectangular. We have two methods. Multiply by R, square both sides. Oops, where am I? Down here. Anybody have a suggestion? What do you want to do? Multiply both sides by R. It doesn't really get us anywhere. How about squaring? Okay, that doesn't really give us any get us anywhere. Anybody have any other suggestions? Okay. You can still draw it, though, right? It's still an equation that can still be drawn. You got to figure out what it is to draw it, though. That's what we're trying to do, is get it to be in a form that, wait, don't we know what that is? Melanie? Theta is an angle. What do you mean?
Well, if we know that theta is an angle and it has an end point at a certain probably you can do that.
Wait, Kara, you have a suggestion? Oh, that wasn't your hand. Okay, don't forget about what we know here. Tangent both sides? You can do that. Seems like that would create, so take the tangent of both sides. Okay, what's the tangent of pi over 4? Don't we know what tangent of theta equals? In our toolbox. Y over x. Y over x equals 1. So I still don't know how to graph that. It's not in a form that I recognize. Elena?
It's just like straight, like a 45-degree angle.
So y equals x, which is 45-degree angle. That's theta equals pi over 4, or y equals x. Good job. Straight.
Did you have to do that though? Because the angle they gave you was
Yeah.
4.
It makes sense now that we've gone all the way around it, right? Well, it's sort of dumb, like, wait, why did you start? It's the same dumb as this. When you would, in your head, you'd say r equals 4, you're like, oh, I'm done, that's polar coordinates. So it's the same dumb, you know, it's like, we just didn't know it, you know what I mean?
It seems like a lot of work for like
But what we were trying to do is we were trying to, and I thought maybe Lauren was going to get there when she said something about. No, I thought you were going to get there. I forget what you said, but you were just like, you then assumed that it can't be drawn. But theta equals pi over 4 is a line like that. Okay. R equals, but anyway, we're going to do all the graphing, the basic graphs. So you're going to recognize them next week.